So let's now proceed to sample problem 5.3. It states here that a coiled spring in a waste trimming exerciser requires a force of 54 newtons to compress it by 0.20 meters. Find the force, or A, find the force constant of the spring. B, how much force is needed to compress the spring by 0.50 meters. And C, how much work is done in compressing the spring by 0.5 meters. Alright, so we will start with finding out the force constant of the spring. In this case, we need to use the equation 5.2 to find out the force constant. So equation 5.2 is F, or force, is equal to, where F is of course the force and K right there is the force of, or force constant of the spring, this one, and delta X is the elongation or compression of the spring. Alright, now we need to manipulate this equation for us to find out what is the spring, or the force constant of the spring, which is K. In this case, we have since we are after K, we have to eliminate delta X on the right side by dividing both sides by delta X. So we can cancel this. Alright, now our equation turns out F over delta X equals K, or we can write that in this form. K equals, that is just the same, F over delta X. So from this, we can substitute values based on the given problem. Right, so now K is equal to, F is equal to 54 newtons. Since we are talking about compression here, that means F becomes negative. How does it become negative? So for example, you have here a coiled spring. Now, originally, the delta X, or the displacement, or the length of this spring is from this point to this one right here. Now, if you are going to compress that, i-compress nimo, mo-apply kag force, patubang dito. That means the force applied is on the negative direction, or the opposite direction. That makes F here negative 54. So we get 270 newtons per meter. Alright, for letter B, we are going to find out the value of how much force is needed to compress the spring by 0.50 meters. Should I write it here? Diri na lang nato ibutang para makasave tag space. Kay kalas. We have to save resources. Alright, in this case, we need to use the force constant, or the value of K, which is 270 newtons per meter, as well as the equation 5.2 to find out the force needed to compress the spring by 0.50 meters. So our equation would be the same, equation 5.2, that is sibutang value ni K, 270 newtons per meter. Alright, now the equation is, or delta x pa di ay, delta x is 0.50 meters. Now the equation 5.2, and then directly substitute these values right here. For K, we have 270 newtons per meter. Multiply that to delta x, which is 0.50 meters. We get half of 270 is 135. As for the unit, hindi rin ako isolve na lang sa ibabaw. So if you are to multiply Newton per meter, Newton per meter with another meter, that would be Newton meter over meter, cancel. What's left is Newton. So F, or the force needed to compress the spring by 0.50 meters, is 135 newtons. Now we have letter C. For letter C, we are going to use, or we need to find out the work done in compressing the spring by 0.5 meters. We are going to use the equation 5.3. That is equation 5.3 is work done equal to 1/2 K times delta X, or square of delta X. Since we already have values for K and delta X, we simply have to substitute these values to find out the work done. K is again 270 newtons per meter, and delta X is 0.50 meters. Okay, so 1/2 times 270 newtons. Square of 0.50 is 0.25. Multiply that to 270 and 1/2. You will get 33.75. What will happen to the unit now? Okay, the unit will be dari lang, Newton per meter times meter squared. That is Newton meter squared over m. Cancel, cancel. What's left is Newton meters or joules. So the work done in compressing the spring by 0.5 meters, 0.50 meters, is 33.75 joules. There you go. You can also approximate that to 34 joules. Okay, let's proceed to another sample problem.